Why do we know so little about the human brain? One big challenge has been understanding brain activity. That is, until a collaboration of 12 different labs just published the first full map of a mammal's brain activity. What does this mean for the future of neuroscience? My name is Chloe, I'm science correspondent with Biotech TV. Let's break it down in 60 seconds. To capture brain activity from neurons, neuroscientists use electrodes implanted in the brain. However, there is always a limit to how many electrodes can be connected at any one time. That's why it took 12 labs, each taking a different part of a mouse brain, and compiling together over 650,000 neurons worth of data. Not only that, but this international team used this setup to test how decision-making brain activity changes in the brain. In this setup, they taught mice to move away from a target for a food reward. They then gradually got rid of the target, but the animals still knew to move towards the same place for that reward. Researchers started changing up where the animals needed to move for the reward, and started monitoring the brain activity as the mice learned this new expectation. One might assume that a certain region of the brain might light up with increased brain activity as the mouse learns this new expectation. Instead, the data shows the brain activities were not localized to any one area. Specifically, they saw the expectations grounded on previous action, not previous stimuli, all backing up the idea that no one brain area causes decisions, and paving a new way to study brain activity.